In this lesson, let me give you a quick introduction to event sourcing, which is a popular but often misunderstood pattern for implementing event-driven systems. In most applications, the system state is saved as point-in-time snapshots, such as the current value of someone's bank account balance. While this lets us answer the question of how much money do they have right now, there's no history of how we got here, which is often a regulatory requirement. So you often see a history table that records how the balance for an account has changed over time, where we have a new entry every time the account balance changes. From here, we can see that on the 28th of May, the account's balance was deducted by $10, but these are still point-in-time snapshots. They're not events, and they don't tell us what the deduction was for, if it was a cash withdrawal or bank transfer or any details at all. And in the real world, you will see something more like this on your bank statement, where every balance change is recorded as an event, along with some description such as a payment reference. And every event captures the change in the balance, and you can use these deltas to work out the new balance after each transaction. This is an example of event sourcing, which is when we model state as a sequence of events instead of a collection of snapshots. And the bank statement is a good example of this because everyone is familiar with it. To work out the current balance in the account, we can go all the way back to the initial deposit that opened the account and apply the event against the previous balance to work out the new balance, and repeat this process to work out the next balance and so on, all the way to today's balance. Storing the events and the deltas instead of the snapshots of the account balances gives you a complete history of state changes as a sequence of immutable events. So you have a full audit history out of the box. And if you need to process these events differently, perhaps you realize there was a bug, and when the user made some cash deposit on the 24th of May, they should have received a bonus of $10. Then you can fix your business logic and replay the event from that point and recalculate the balance values to work out a new balance for today. This ability to replay events and apply different logic gives you a lot of flexibility to be able to reconstruct the system state in different ways by just replaying the events, perhaps after you discover a bug in the system and now you need to reprocess all the previous events to fix the account balances. And that's great in that particular situation. But if you have to fetch and process thousands of events every time the user queries their account balance, then that's a lot of work and it's very inefficient, especially when you haven't changed any business logic and there are no new events, and so you're just going to arrive at the same account balance value every single time, which is just wasteful. And one way to address this is to create snapshots periodically, so that after every, say, 10 transactions, you will create a new snapshot. So we know that after the cash withdrawal on the 24th of May here, the new account balance was $90. So when we need to work out the current balance, we just need to replay the event from the most recent snapshot instead of replaying all the events from the beginning. And after we've worked out the new balance, maybe we can even create a new snapshot on demand so that the next time we need to fetch the current balance, we don't have to do all that work again. But you might be thinking, well, that sounds a lot like a caching. Can we just cache the current balance instead? And every time we save an event that affects the balance, we will just update the cache. And if we ever get a cache miss, then we can recalculate the current state from the events, which will be expensive, but we will only do that if there is a problem with our cache or we decided to flush the cache because we made a change to the business logic and need to replay all the events anyway. So we can work around this inefficiency with event sourcing, but event sourcing also makes it more difficult to deal with race conditions. A classic example of this is when you check into a flight. If multiple users are trying to reserve the best seats, then there is going to be a lot of contention. You might have a situation where multiple users are trying to reserve the same seat at the same time, and these requests are all processed concurrently. By going through the sequence of events and checking if the request is valid, but based on the event we have, all three request handlers are going to think that the seat is available. And all three are going to add a reserved event and the seat will be triple booked. And that's not good. So to prevent this, we can introduce a reservation table where we can use DynamoDB's conditional rights to ensure that only one user is able to reserve the seat and the other requests are rejected, and that solves our problem. But now we're back to storing snapshots. Is there some other way to solve this problem without using a separate DynaDB table for locking? One answer to that is the CQRS pattern, or Command Query Responsibility Segregation, which is a pattern that separates the read and the write operations into different workflows, and it can help address the problem with these race conditions. So in the next lesson, let's look into CQRS and what it's all about. Hi, I hope you have enjoyed this video, and if you do, why not check out these other videos and learn more about serverless development.